Welcome to Let's Get Defensive, the show where we talk about using your elbow to defend yourself.
Ouch! Ow!
That
was it, was it? That was your elbow.
That is my elbow.
That has got hurt. No wonder
Yeah.
you wimped out of last week's session.
Yeah, so we're going to talk about how you can actually defend yourself from concrete by blocking it with your elbow.
That's defense for you.
While that sounds painful, I think you got the wrong show again. This is Let's Get Defensive, the show where we take a deep dive into what's going on in the aerospace and defense world, right? I think through a product lifecycle lens. Make sure that's accurate.
So coming up, we're going to have Rocket Lab, Rocket Sun, Airbus, Honeywell, Merlin, OHB, the European Space Agency, Rheinmetall, General Dynamics, Rink America, Kinetic, Bombardier, CACI International, U.S. Navy, BAE Systems, Kongsberg. That's a lot to fit in.
That's a lot to fit in. Well, let's jump straight into it. It sounds like Rocket Lab is installing a colossal automated fiber placement. We'll shorten that to AFP machine to make Neutron the largest carbon composite rocket yet. 99 tons, 39 feet tall. I mean, this is a robotic behemoth, custom built by Washington-based Electroimpact and designed to automate production for Rocket Lab's massive rocket parts. Sounds like the AFP machine is going to build Neutron's 91-foot interstage, the 7-meter diameter first stage, the 5-meter diameter second stage tank, really covering the entire rocket length with automated precision. This AFP machine is capable of laying 328 feet of carbon fiber per minute.
Wow.
The AFP, that's crazy. Equipped with real-time inspection tech, instantly detecting material flaws, the setup is projected to cut Neutron's production time by a whopping 150,000 hours, which is a lot of hours and equally a lot of money, which enables Rocket Lab to meet ambitious launch schedules.
Yeah, this AFP thing is crazy. 150,000 hour reduction in construction. 300 and whatever feet of carbon laying per minute. Really, really crazy, I got to say. Effectively managing, because I think what it's doing, it's adjusting as it's pouring, as it's shooting this kind of carbon out there. So the backbone of this is going to be the data. It's that consumption of data to know where it's at, because it's pretty autonomous by the sounds of it. So massive data generated by that AFP machine, real-time inspection system to optimize your production and maintain quality every step of the way. That is got to be the number one challenge for this beast.
I think, first off, this whole thing is fascinating. We're looking at almost a football field being laid per minute. I mean, that is fascinating to think of, right? When you're doing something with all of this speed, this advancement, quality is going to be a concern. And it's my number one concern for the rocket production portion of this, because you have to have a machine that checks the quality, and the machine here can actually check itself. So it's fully automated real-time inspection system that hunts for the tiny defects throughout the laminated carbon composite and alerts the machine operator of any issues before the next layer gets laid down. So we have assurance that everything is correct and is going to meet quality standards, all happening by the machine itself.
Okay, agree and a disagree. You're right, quality is an issue, but you need the data in the first place, and the data in the first place is going to be massive. It is going to be the big data that's coming in. So that AFP machine is going to have to churn out huge amounts of real-time inspection data. So without that as the solid core strategy, those valuable insights could get lost in, frankly, a data deluge. So that's going to lead them then to missed opportunities for process improvements. So really, the utilization of that data is going to be key to staying competitive, efficient, profitable, and making sure those rocket components are going to meet the stringent quality standards that are going to be laid out.
So I think that, well, you are correct, just not as correct as you could be. The size of the whole operation, we've already mentioned, is impressive. The speed, the scale, and I mentioned that for me, the number one for the rocket production was the quality. But I think what might even be more important here is looking at the machine's maintenance itself. When you have downtime on this machine,
Yep.
losing a lot of production. When it makes mistakes, you're losing a lot. So I kind of want to look at the PLM for the product that's supporting the rocket PLM, right? We have a machine that's made to help with the rocket manufacturing, but that machine, what about its maintenance, its downtime plans, its predictive maintenance? What we have to do something here to make sure everything works smoothly once you put this huge investment in.
I mean, solution to that whole predictive maintenance thing is an AI industrial layer over the top of that and predicting that whole maintenance thing. So that's that. If we can go back into critical thread, we can talk about SBOMs and scheduling and planning and all that kind of good stuff and disassembly of the AFP. But I think as a solution, speaking to the whole data thing, which is clearly the number one challenge, in my opinion, the critical thread infrastructure are the foundations of success here. Establishing that centralized data management platform that seamlessly integrates with the AFP machine. Then when you've got that in place, then you've got to have cross-functional teams to interpret and act on the data. So you need that collaborative platform running. Then you've got to implement your real-time analytics dashboards to monitor the production metrics, identify any trends or any anomalies that are coming in real time and instantly. And then you've got to sprinkle a little AI into this whole thing, I think. So you've got your predictive analytics. So your forecasting intelligence to tell you what's likely to be happening in the future as well. And then deploying your machine learning algorithms to continuously improve as you go forward. So a lot of AI stuff, and getting that critical thread foundation for the data for me is the solution.
So there you have it. 3 number one challenges.
Whatever disagreements you guys are having, keep leaning into that. I like seeing this back and forth. So keep going. And Andrew, you've got a leg up. Like it looks like Bryan is without the use of one arm this week. So
no, you said leg up. You meant arm up.
That's right. I meant arm up. You got an arm up. That's right. The Levant close-in air defense system developed by Turkey's Roketsan successfully developed or completed its debut live fire test, which is a pretty major boost for Turkey's maritime defense capability. Designed for short-range defense, Levant defends naval assets from drones, helicopters, aircraft, cruise missiles. Built on Roketsan's Sunger missile tech, sounds like Levant features a dual-mode seeker, both passive RF and imaging infrared, making it adept at tracking evasive, fast-moving threats like sea skimmers and supersonic missiles. The 11 missile vertical launcher offers a range of 11 kilometers. So how's that for close range? 11 kilometers and 360-degree coverage. Modes from manual to fully automatic, integrates with ship sensors for rapid target acquisition. Sounds like it's going to be replacing the US RAM 116 RAM. I'm excited for this. I mean, future applications for this could be way beyond just naval vessels, could include helicopters, could include drones. There's a number of different things there, but
this is an easy number one. It's an easy number one, but I'm going to let Bryan go first.
Obviously, quality is a concern. It has to work. Failure is not an option. However, working is what all products should do. So it's probably a given, and Andrew's going to roll his eyes when I mention quality.
They're already rolling.
So I could say that my number one is actually going to be design and change management, looking at the testing needed. Even though I talk about that a lot and I talk about the significance of first fire, I'm going to say my number one here, just to keep throwing you for a loop, is looking at the requirements involved.
No. Well, that's interesting. Yeah, it could be. You could tie that in to defend yourself in a second as I come out on the all-out attack for you, because you've just eradicated a long-standing short-range defense system. You've replaced it with the brand new shiny system. But let's be honest, the last few years, things on weaponry have really evolving fast. So I think it's not about all of that requirement stuff, but it's really about requirements today and it's requirements for tomorrow, because it's really, really changing. So future proofing the 11 air defense system to effectively counter rapidly evolving aerial threats through advanced technology integration is the number one for me. So it's that future proofing challenge.
I mean, this thing can operate autonomously. It can be integrated with the ship's combat system. So it's versatile across various naval platforms. The missile has a cool range, the 11-kilometer range, mounted in the 11 missile vertical launcher with 360 degrees coverage, capable of different operating modes, manual, semi-automatic, fully automatic. But all of this has to integrate seamlessly with the ship's onboard sensor systems, with the radars, with the electro-optic sensors. Being able to do so means in order to make this integrate correctly, I have to know what are my requirements of integration. What are my requirements of the systems this is going to talk to? What kind of data do I need to send back and forth?
I agree, but you've got to think about the future as well, because you don't want to buy something that's great for today and, you know, obsolete tomorrow. I knew I'd remember that word eventually, because you've got an ever evolving threat over the next few months, never mind years. You got hypersonic missiles coming in, stealth drones, swarm attack drones. Imagine that now. You've got like 1,000 drones coming at you at once. You've got to be able to handle that for short range air defense systems. And if you can't get ready for that, you're going to be a dinosaur. It doesn't matter what requirements you gather today. If you ain't ready for tomorrow, you're a dinosaur. So
your requirements have to match
superiority.
They've got to be requirements for today. They've got to be requirements for future proofing.
Yes,
because
that's what you missed.
It's envisioned as a replacement for the foreign close-in weapon system, like what we mentioned, the RAM was that? Yeah, the RAM 116 RAM, which Turkey previously integrated into their was it the MIL gyms? Yeah. So how do we ensure proper integration of systems functionality and necessary data to the integrated platform tech? The answer is proper requirements management, requirements traceability.
Solution is requirements traceability. The solution, but the biggest problem is future proofing. This is my argument, and I'm going to stand firm to it. So establishing end-to-end requirements traceability framework connected to every granular product requirement, to design components, to your testing protocols and your deployment processes. Again, you've got to make sure you're future proofing as well and simulating for that. So utilizing formal systems engineering tools to model the entire system holistically, ensuring all your integration aspects are accounted for, number one. Number two, bring in some more detail now. So develop your requirements traceability matrix, your RTM, map each requirement to its corresponding design elements, the test cases and the validation procedures, and make sure that it ensures no requirement today and tomorrow is overlooked during integration.
You're not wrong.
I need a bit of AI as well, though.
Well, yeah, you've got to take your salt and pepper shaker full of AI and sprinkle it on. I mean,
I think you've got to sprinkle a little in here. I think, using some kind of AI algorithms to automatically analyze requirements documents, identify potential inconsistencies, redundancies, or gaps. I think that's going to be part of it as well. Because already the solution, a problem I've said, is the future, not just the present, because I'm going to keep saying that just to prove a point. You want AI in there on your side as well, getting through that massive amount of data. There you go. I'm going to back it off now and get off my soapbox.
I like it. Airbus U.S. Space and Defense has just demonstrated its new Lakota UH-72 drone helicopter for the U.S. Marine. Look at that thing. I love that. I think it looks cool.
You wouldn't be a passenger, would you?
There's no windows on that thing.
There's no windows on that thing. No. It would be an interesting.
I don't know how the computer can see to fly without windows.
Yeah, I know. It's crazy. It's crazy how it works. I also feel like if I was sitting in there, I would get extremely airsick, maybe is the best way to put it. Not being able to see what's going on.
It's an autonomous helicopter. Why would you be sitting in there?
Yeah. Because it can carry. Well, we'll get to that. We'll get to that. Known as the Unmanned Logistics Connector, the autonomous UH-72 variant designed to ensure supply lines stay open without human risk, which does sidestep the traditional vulnerable transport options, but is capable of carrying up to 4,000 pounds, which means I could easily fit inside for a ride, maybe one of these days. The ULC can cruise at 135 knots with a range of 350 nautical miles, making it ideal for these.
You won't even go in an eVTOL, never
You're
mind
right, I won't.
drone helicopter.
The eVTOL with windows. Yeah. Although, if I'm not going to know we're going down, I don't know. It might be better for me not to have windows at all. This is good. I mean, it's built on the Army's proven UH-72B Lakota model. Boasts design tweaks, a 5-blade rotor, advanced engines, which of course is going to enhance lift and hopefully simplify maintenance for them. The demonstration is part of a rapid prototyping initiative by the Department of Defense, the DoD, supporting the U.S. military's push toward agile unmanned logistics. I mean, testing is going to continue through 2025, expected to expand its autonomy features. It's really reinforcing Airbus in their role in helping modernize everything military and defense in a cost-effective way.
After this, it doesn't really matter what Bryan says, because I think we all know what I'm about to tell you is the number one challenge. Autonomous functionality is the number one challenge. You've got high-risk zones with a continuous feedback mechanism as well as being autonomous. That's the biggest challenge. That drone helo has got to meet rigorous requirements for autonomous supply logistics, high-risk environments, particularly integrating real-time feedback from warfighters as well to refine its functionality hereinafter. There you go. That's the number one. Do we just move on to the next one now?
Yeah. In order to have autonomous functionality, in order to have this is something that makes sense with the people who are going to be integrated, humans are still going to integrate with this, right? In order to have this, you're right, requirements are going to be huge. These requirements had to be integrated into the design for the functionality, into the supply logistics. And there's a feedback loop from requirements to change to design that was very significant in getting this design to happen. The integrated warfighter feedback in the phase of the contract we're talking about here to meet all the requirements and give insights to deliver the right capabilities to the U.S. Marine Corps. So this close integration of operational feedback is what's helping Airbus to be aligned with the operational needs of the U.S., strengthening the development of the ALC system. So all of this together means to have the autonomous functionality, we have to look at how we're taking the actual requirements of the drone functions here.
I think you just agreed with me. The number one challenge is the autonomous operation. That's the number one. The requirements are going to be changing. That's the whole idea of machine learning, isn't it? You know, it's going to be different environments it's going to have to operate in. So I hear you. So I think the bottom line is this 72, the UH-72, has to adapt to various supply logistics scenarios. Yeah, carrying heavy loads over significant distances. But yeah, I think it's just the autonomous operation is the number one challenge.
And it shows the collaboration that that happen here and tend to need to happen in a lot of design processes between the customer use case and the design. So in order for this to work, you need to have a system that lets us figure out those requirements, track those requirements, trace them through the whole process.
That's the solution. I agree.
Yeah.
That's the solution. So you're right. Requirements trace with feedback integration. So you need a system to do all of that. It ensures operational feedback is directly linked to design elements, enabling rapid iteration, et cetera, et cetera. And then you might want to bring in your AI for enhanced feedback analysis. So you're getting all this feedback coming in. You want an AI over that to be able to filter that and decide what is the real critical parts of it for predictive feedback as well going forward. So yeah.
No, I feel like we've really upset Greg by agreeing too much.
Yeah, way too much. Way too much. I separate. Let's hit the reset button real quick.
Yeah, I think the only thing we can possibly do is take a commercial break to let you recover.
Thank you.
I'm telling you, BAE and Rheinmetall are killing it out there. They
Yeah.
are busy, really, aren't they?
Those self-propelled guns, look, they're howitzers. I had to look up the article real quick. Self-propelled howitzers look kind of neat and also terrifying at the same time. Like,
Are they more terrifying than flying in an autonomous helicopter with no windows?
agreed. Yes. Maybe.
And less terrifying than all of those robot military things that we just saw a picture
Yes,
of as well.
that's right. Yeah.
true.
Yeah.
Plus, you've got laser guided shells now.
Yes.
Really, yeah, lot.
Yeah. There's a lot. There's a lot going on there. Honeywell and Merlin have teamed up to integrate Merlin's autonomous flight tech with Honeywell's Anthem avionics, which hopefully is going to reduce pilot workload on military aircraft, moving toward that single pilot or even uncrewed flight, which, I'm not a huge fan of. But the partnership is going to retrofit existing fixed wing military planes with automation capabilities, helping bridge that gap as the military is grappling with pilot shortages. But by enabling single pilot operations, it should really improve fleet efficiency, which is going to benefit both military and commercial sectors. So you've got Honeywell's Anthem suite handling avionics tasks. You've got Merlin's automation streamlining flight tasks, enhancing mission control. Both are kind of bolstering safety on both ends. I mean, the automation really is just reducing crew, but also overall fleet management. It's going to help with that. So should be crucial, especially as the need for these pilots and trained pilots are going to.
Did you just say that reducing crew was crucial?
I think so.
Wow.
Yeah. I think that
like a union HR representative.
First off, there are windows on these, so you can fly in it. Secondly, I think probably Greg's number one here might be looking at either the crew size or the fact that there's a pilot shortage. That's interesting. But my number one is going to be, we're looking at retrofitting fixed wing military aircraft with Merlin's autonomous system to eventually get to uncrewed flight, which means old systems, new fancy tech being put together. We've covered this sort of thing before. But for me, it means I want to look at how are we going to integrate the new fancy tech with the old systems.
I hate to agree with you, but I'm going to have to. You've got it. I mean, you're right. Integrating Merlin's autonomous flight tech with that existing Honeywell's avionics, all retrofitted in military aircraft. Yeah, it's integration.
I mean, if I wanted to try to disagree with you just to make Greg happy, I think I would go with talking about the collaboration being important between our companies here. Like there's collab that has to happen between the Merlin, between the military aircraft, between Honeywell, all this kind of put together. But no, I'm sticking with integration.
Yeah, agree. So do we agree on the solution? That's the thing. And for me, I'm running dangerously close to probably you agreeing with me again, because I'm going design and change management, implementing comprehensive design and change management that incorporates both Honeywell's and Merlin's systems, making sure that they have control over every single integration step is key. You've got model-based design you want to bring in here to create detailed digital models of the avionics autonomy integration, allow your teams to visualize and to simulate potential issues in those models before physical implementation. Are we going to agree?
We are, sort of.
Okay.
So I want to actually dive into a more specific area of looking at some of this design you're talking about, which for me here is the simulation capabilities that we have within modern software. With our current technologies, we can simulate a whole lot of what's going to happen to foresee problems that could happen. So we're able to see, simulate, look at where are you going to put the pieces and that are driving the autonomous operation? Where in the plane do you put these? How do you put them in a way that doesn't interfere with any humans that will be on there, even though they may not be needed because it's an uncrewed flight? You still might have needs for them to be on for other reasons. So they have to be able to fit and to work around the systems. So we can actually use ergonomics inside of simulation to see how humans can function inside of here. So for me, for a lot of this, I think the simulation portion is going to be the best part of the solution we can use.
So if you're going to go simulate, so I'm at design and change, and you're at product validation and simulation. If you're in simulation, so that, a lot of the software vendors out there are going to say, yeah, we've got AI simulation tools based upon semantic ML driven models. I think what's going to be interesting now on simulation is the whole generative AI piece of it. So literally your simulation tools self-learn and improve. I think if you're going to bring simulation in, you want the generative AI simulation, not the traditional algorithm, machine learning, semantic-based, role-based stuff that's out there today. So modernize it. So again, I guess we agree on the back end.
Sorry, Greg.
Listen, we'll work on it. We'll work on it, guys. We'll do some debate practice over this next week. American Rheinmetall and General Dynamics Land Systems have just passed key design reviews for the XM30, which is the intended replacement for the Army's aging Bradley Infantry Fighting Vehicle, IFV. Both teams are going to deliver hybrid high-tech vehicles featuring remote-controlled 50mm turret, crazy anti-tank missiles, active protection systems, enhanced sensors, all the bells and whistles. The XM30 program, which is valued around $1.6 billion for development, but then another anticipated $45 billion overall, aims to field about 3,800 new vehicles. Sounds like they're looking to get into service by 2029, finalizing by 2027. I mean, the Army could see the XM30 prototypes within 18 to 20 months here. It's crazy. And then, of course, you've got their partners that are working with them as well. So Rheinmetall's team includes Textron and L3 Harris, while GDLS has GM Defense and AeroVironment. They're going to integrate features like Switchblade. I know we've talked about that on a previous show. Advanced cyber capabilities. There's a lot going into this thing.
The thing here for me is you talked about 2029, and this is this kind of 3 years out, 4 years out, 5 years out stuff. And this is what makes me nervous, and I think is the number one challenge. So when they bring this infantry fighting vehicle through, is to make sure that it's ready for modern battlefield demands, which are going to be super versatile. They've got to get the protection right for the new threats that are out there. They've got reduced crew requirements, and they've got to still integrate that advanced digital hybrid electric system into the whole thing as well. And that's 5 years down the road. So you've got to make sure that you're ready for modern battlefield. That for me is the challenge today for something that's going to be in the field in 5 years' time. Too slow.
I just want to take a moment, okay? Remote controlled turret with a 50mm cannon, possibility of a 30mm version upgrade, along with advanced self-protection capabilities and digital architecture. Is this a future weapon of the week?
Easily. Has to be.
I thought Commercial Break maybe had some of them.
That's true. That's very true.
For me here, I'm looking at how do you design this? The final selection for the XM30 design is projected as, what was it, 2027 with the entry you said 2029, right?
Yeah.
So that sounds like a while, but in order to, it's not just 2029, it's not just 4 years from now to say, hey, we have a good design, but we actually have to get the design, get it through approvals, get the whole thing designed, approved. Hey, we're going to do this, and then start making it. So the only way to do this is going to find digital tools to accelerate the design process, to get rapid feedback from the soldiers at all the stages through this design process.
Yeah, again, that sounds like a good solution to the original problem that I detailed. Which is to be future-proof, ready for 4 or 5 years down the road. Making sure that those design adjustments are based on real-time feedback are going to be essential, and based upon future scope feedback, which is, again, a bit of an AI thing, isn't it? So meeting those accelerated timelines without compromising on performance is going to be critical to success on this one.
I mean, I think that interactive feedback during design process is the power that we have with a good PLM platform that allows for your interactive feedback, your interactive collaboration with the users. And that's done not with physical tests, with prototypes, but also with virtual testing. That's going to let you have a cheaper and faster way to get those design adjustments to meet the operational requirements. And I think both companies here have a lot of modifications that they make they've also made from interface tweaks to significant structural changes.
Mm.
And that just shows, I don't believe that this is the kind of thing that could happen as fast as it does if we were looking at, say, 15 years ago. I think we have technology that allows for better interactive feedback and better interactive collaboration that allows for things like this to happen.
Yeah. Okay. The solution, I'm going to go back to the challenge that you turned into a solution, which is design and change, including digital design tools, making sure you've got that real-time soldier feedback coming in, agile iterations to adapt quickly to changing battlefield requirements. You've got to have model-based design, change management, and continuous improvement feedback as part of that D&CM, design and change management solution embedded. And then I would use AI for analytics to help you prioritize and adapt those inbound design modifications.
Greg, did you notice that even when he thinks I'm right, Andrew has to phrase it like I'm wrong?
Yeah, I did. I truly don't understand what is happening between you two. So I can't tell if you agree or disagree. Who knows? It's too much confusion for me. Anyways,
it's all showmanship. It's a staged reality show.
I don't know that it is, because we have our arguments off screen too. Rank America and UK-based Kinetic are advancing hybrid transmission tech for military vehicles in a new partnership focused on Kinetic's EX drive system. The EX drive is basically combining electrical and mechanical drives, offering, of course, that efficiency and flexibility between the two in propulsion for both crewed and uncrewed vehicles under 20 tons. Now, Rank America aims to expand hybrid options, which targets the UGV market beyond, highlighting fuel consumption, improved maneuverability, lower maintenance costs, all of the above. It does sound like the COO was emphasizing the tech's potential for lightweight, agile military vehicles. But this also follows Rank's recent debut of the world's first hybrid tank transmission for 70-ton vehicles, which, I don't know, there's a strong push here for hybrid autonomous mobility, modern defense needs.
You just said 70-ton vehicles.
Yeah, 70. That's massive. That's a heavy vehicle.
That's getting to numbers I don't think my brain's wrapping itself around right now.
Yeah.
So we've got a collaboration here between two companies aiming to meet the evolving needs of modern defense forces that are going towards more hybridization, electrification, carbon neutral options. They're looking for improvements in fuel efficiency, mobility, reliability. So my number one, because we're looking at taking this transmission, fitting it into existing vehicles, integration.
We're going to agree. Integrating, as you say, that whole hybrid transmission into Rank vehicles, diverse performance requirements across various weight classes, and uncrewed ground vehicles. Yeah, it's got to be integration, hasn't it? It's got to be number one.
Just as a side note, thanks for agreeing, but also 70 tons is 140,000 pounds.
Yeah.
Those are numbers I understand better. It's a lot.
Yeah.
So we're
like
looking at
the crater that leaves.
Enhancing the performance of military vehicles by offering better maneuverability, higher torque, increased reliability, reducing maintenance cost and fuel consumption are all amazing, fantastic, worthwhile benefits. But how do we ensure a quick and cost-effective installation?
Yep.
Working correctly with the systems that are already on the vehicles.
Yep. It's
How
a
do we do
solution. This is an obvious one. I think it's product structure and configuration management. Implementing, organizing, and managing all of those different configurations of the hybrid transmission system, allowing seamless adaptation for different vehicle platforms. Let's just jump into kind of PS and CM, product structure configuration management. You've got to develop and maintain a detailed BOM, number one, for each variant of the EX drive. You've got to tailor that BOM for different vehicle weights and operational needs. and configuration baselines to track that design version for each application. You've got updates to have come through. You've got adjustments for various vehicle types.
But
So
wait, there's more.
Okay.
I'm going to say we're about to see some AI sprinkled in.
You've got it. Absolutely. This thing is getting to be, this is a beast. It's a beast, isn't it? So it's AI-based configuration management tools that they will optimize your component selection. They will track performance variations of those components across the various vehicle classes. You can't just have some kind of human collaborative platform on its own. You've got to bring that AI over the top underneath to extract that data really quickly.
At this point, I'm just going to come to expect that you guys agree on everything, and I'm just going to keep rolling with it. Bombardier is revving up its production on its latest and greatest, the global G8000, which is slated to be the world's fastest business jet when it debuts next year in 2025. Major components for the G8000 are being built in Bombardier's facilities in Canada, US, Mexico. They've got an international footprint here. The G8000 itself achieved a supersonic test speed back in 2021 and is set to fly up to just under Mach 1, Mach 0.94, positioning it as the fastest civil jet since the Concorde's retirement. I mean, this jet isn't just fast here, though. It's built to go the distance, impressive range, allowing long-haul flights nonstop from Los Angeles to Sydney. Crazy. Customers can expect to be able to step aboard the G8000 in the latter half of 2025. It's still under 12 months. Crazy. Blend of speed, luxury, cutting edge technology. I'm wondering what the ticket price is going to be. But the Bombardier executive team is really crediting this achievement to its workforce, which I'm always happy to see when an organization is lifting up its workforce. And then, of course, commitment to its top tier manufacturing standards.
The challenge here, so if you look at that kind of commercial aviation thing, everybody's got backlog right now. Everybody's got backlogs. Boeing, Airbus, Embraer, I think Gulfstream have got challenges as well. So they've all got these backlogs going on. Therefore, the number one challenge is going to be scaling production across multiple sites, because it's not just one plant. These guys are sitting across 2, 3, 4 different plants that they got to work to and deliver for 2025, you said.
Yeah. I mean, that is an interesting point, but the number one challenge is going to be reading the Bombardier on the bottom of the plane while it flies by so fast you can't see it. I do like having the name on the bottom of the plane. That was cool for the photo ops. But what we're talking about, something that's going to be the world's fastest business jet in 2025. It's the first business jet to go supersonic in testing. It's going to be able to go from LA to Sydney, which is over 7,500 miles in nonstop. Talk about innovation and design. How did we get here? I'm looking at a process that involved great iterations between testing, between design. I think my number one is looking at the change management process overall. Correctively and efficiently using the feedback from testing into that process, into that design. I think that's what you have to have in order for this phenomenal thing to happen here.
Yeah, but here's the point. It's got to happen by next year. So here comes your production challenge. High speed, range of this G8, the demands for precision in manufacturing, plus you've got to get it operational across Canada, US, Mexico, adds to all of this complexity. You've got to get your quality control critical before it even goes in the air. So it's, for me, again, it's production at scale and meeting those timelines in 2025. Good luck.
While you're talking about that, we also probably should mention while you're looking at producing at scale across multiple locations, there are supplies that have to be delivered to all these locations. And there may be
supply chain now.
And you're also looking at different countries, right? So like the required, the ability to get stuff to different countries that meets the same quality standards and all of that together is also a pretty big factor to getting to the point that you want, which is being able to actually make them.
Yep. So I'm going mess mom, but I'm also going to make sure just to lean in and satisfy Bryan's thinking of change management, etc., is make sure that we've got product validation and simulation running. So running virtual tests for major components to preempt future quality issues, sync that simulation data across the sites for uniform standards. So I think you've got to have your PV&S running as well. And then, of course, analyze that production data for consistency across your sites, flagging variances early. So you've got your mess mom and your AI operating together. So a few things there, but I only did it just to make sure that Bryan didn't feel less.
Does that make HR Greg happy when we disagree but find harmony?
Sometimes, but that's not what I'm expecting here. I'm ready for knockout, drag out fight.
You need a break. Okay, we'll recombobulate here.
Sounds good. I'm excited to keep an eye out. I'm excited to keep an eye out for Embraer's new aircraft that they're considering to compete with Boeing.
I wonder if that's got anything to do with the backlogs of Boeing and Airbus and all those kind of things. It's like we need to bring through something to compete. Yeah, makes sense. And India again. It is. Stuff in India for defense. Yeah.
India is nonstop right now. It's cool to see. It's cool to see. In competition, we know is always healthy, unless your name is Bryan and Andrew, and apparently you're averse to it. The European Space Agency, ESA, awarded OHB £280 million to develop 2 satellites for the Earth Explorer 10 Harmony mission, we've kind of brushed this in previous weeks, aimed at enhancing Earth observation. This mission is actually marking the first time that OHB is going to integrate a radar instrument with optical payload on a single satellite, which will enable some more precision monitoring alongside the Copernicus Sentinel-1 radar data. Set to launch in 2029, the Harmony satellites are going to be gathering data on ocean surface changes, glacier movement, seismic shifts. This is going to provide some critical insights into natural events, earthquakes, climate-related shifts in ice formations. I think it's always cool to see information and to be able to pull data like this and build data like this. Now, the Harmony mission does continue the legacy of Earth Explorer projects by bringing that knowledge in, environmental science, aiming to offer new data for climate research, Earth system science, There's a lot of moving pieces and a lot we don't know. So
we're looking at a collaboration here. We're also looking at using radar signals of another satellite. But the big thing we're looking at is something new. This is the first mission for which OHB is going to take radar instrument and optical payload on the same satellite. It's a major technical challenge. At the same time, we're looking to fly the first multi-static radar mission. This is super exciting. So obviously, design here is going to play a huge part. But I really think the number one I want to be looking for is a result of the use case. The Harmony satellites are going to orbit the Earth at almost 700 kilometers in a sun-synchronous path, gathering data, monitoring the small movements and changes in the ocean, the glaciers, the ice sheets, the sea ice, the solid Earth. All of this data needs to be gathered correctly, needs to be analyzed, needs to be transferred, needs to be figured out what's happening with it. So I think the use case for the data and the requirements there is what I really want to focus on as the number one challenge.
Okay. Integration. It's integration. Integrating radar and optical payloads on a single satellite for the first ever time in the history of the universe, while ensuring the system can meet precise Earth monitoring requirements. It's the integration thing for me.
But with that, you're doing all that just so that you can take a look. The whole purpose of these, like their design purpose, is to gather data. That's the purpose.
Okay, that's the purpose, is to gather data. So data is your number one problem, data gathering.
What are you doing with that data? How are you measuring it? How are you gathering it? What are the reasons? Just to say, hey, I want to figure out how to gather data is great.
Yeah.
But I need to know
it sounds really good. It sounds really good.
Transferring it, all of that.
Love it. But the problem is, if you don't have it as a satellite in the first place, you ain't gathering nothing. That combining of a radar and optical instruments on a single satellite poses huge engineering challenges, including you got interference management, you got to maintain signal integrity. So that's the big one. Second is your data transfer and analysis. That's number two, I would say.
But if you don't have the reason to gather the data, you don't have the reason to make the
requirements.
I love it.
Solution, product validation, simulation. Make sure you've integrated the radar optical system to meet those performance requirements under these kind of crazy environmental conditions that are out there. Key to that really is going to be advanced simulation tools to replicate the combined radar optical payload operation in space conditions, ensuring that you've got minimal interference between instruments and optimal data to maintain that accuracy. So I'm going product validation and simulation as the solution for this one. I guess if you've got to bring AI into this whole space.
But wait, there's more. You've got to use an AI-driven predictive modeling to fine-tune the simulation parameters.
Australian just coming anomalies.
I love it. Are you guys agreeing or disagreeing again?
We are disagreeing vehemently.
I love it. It's fantastic. As much as I love the hugs and the cuddles, I do enjoy some healthy competition here. So this is good. Next up, CACI International landed a hefty $805 million 5-year task order to support Naval X with advanced engineering services and technology. Now, this contract is going to be focused on developing, testing, integrating new digital tools, enhancing that those multi-domain operations, boosting naval readiness. The award is building on CACI's decades-long collaboration with the Navy. And then Naval X itself, as I understand it, is acting as like the Navy's innovation accelerator, streamlining advancements, research, development, all the way to practical fleet applications. So it's kind of cool. I know the CEO as we can see, John Mengucci highlighted the goal to address pressing challenges and then quickly deliver operational tech improvements for sailors.
There's the challenge. I mean, congratulations to CACI on winning that contract.
Yeah.
But it's all about now delivering against that contract. So it's rapid development, it's integration of digital tools for Navy multi-domain operations to make sure that the Navy maintains its readiness all the time. So the challenge now is rapid dev and integration into that environment.
Designing fast-track tech solutions within government processes or projects, developing new technology and capabilities for sailors, delivering them rapidly fleet-wide, none of this is a minor undertaking. So for me, the two biggest things are the plan of integration and looking at how to do that rapid development. We agree then. We just agreed.
We did. Absolutely right. So what's the solution? I think we're probably going to end up agreeing on the solution as well, because it's design and change, isn't it?
Yeah, it's the speed of testing. I think it's the speed of testing and prototyping that are going to be the key, which falls under design and change. But how are we ensuring rapid and quality controlled testing in this whole process?
Yeah, but I'm going back to design and change in the first place, using that CAD management model-based design for fast prototyping, fast iterations, and then you've got to bring your change management in on the back end of that into the digital thread. So it logs your updates, it refines your tools from test feedback. So yeah, you've still got your test and your simulation coming in, and then real-time visibility to track your design, your changes, and accessing your system-wide impacts. There we are.
And I suppose we could argue for some AI.
Yeah, I mean, AI, definitely. I mean, simulating your operational scenarios. So into simulation, predicting tool performance, flagging issues for rapid refinements as you go. So yeah, you got your AI in.
Next week, I'm going to step into all of these articles, and I will be picking the problems and solutions, and then I will assign them to the two of you, and they're going to be so opposite that you don't know what's going to. It's going to be great. It's going to be fantastic.
Jeez, what are you going to come up with?
Yeah, we'll see. That's going to be exciting in and of itself. BAE Systems and Kongsberg Defense unveiled the Integrated Combat Solution, ICS, a high-tech situational awareness tool for battlefield vehicles. Now, the ICS is going to be enabling vehicles to share video, target data, and commands in real time, which are going to give warfighters faster responses to emerging threats. Kongsberg is developing the ICS, while BAE Systems is going to be integrating it into U.S. Army and Marine Corps combat vehicles. Of course, future upgrades planned as tech evolves. It sounds like they're using an open system approach. The ICS can connect seamlessly with any platform equipped with sensors and weapon systems. That's huge. Troops are going to be able to control multiple assets, weapon stations, jammers from one single interface.
I mean,
really, this is good.
It's cool. It's super it's fascinating. Kongsberg is going to develop it, you said. And BAE Systems is going to integrate it into the fleet of combat vehicles. So I think that the integration is the most critical. The new tech is always fascinating. It's always cool, but it's pointless unless it can actually be used.
Yeah. It is. It's integration, isn't it? Every step of the way. You can't disagree with that one. How do we fix that issue? I think is the main thing. Especially integrating all of that kind of asset stuff, video, target data, commands, etc. So, I think what's the solution?
The ICS is going to use an open systems approach for what they're saying is a seamless integration on any battlefield platform.
Yeah.
So we have an integrated network that enables it to link to the sensors on different to link sensors of different battlefield assets together. This approach means to me, we have to have a strong handle on what we're doing with our requirements management.
Again. I'm going to go beyond that. I'm actually going to say it's their supply chain integration that they're going to have to work on. I really think so. I think getting that ICS data flow with combat vehicle systems using shared metadata for smooth integration. That data exchange protocol for those sensors for the weapon stations, it's all about cascading that data out into your supply chain, making sure they're fully integrated so you're able to adapt and resolve as you go. So I'm going to bring in a bit of AI for analyzing that data to prioritize those threats. Otherwise, everybody's running around like a headless chicken. So help them prioritize that in terms of AI sensor analyzation.
So we're looking at users can control the weapon stations, the turrets, the jammers from a single interface inside the vehicle. The entire system is designed with integration in mind, so you already said, so I said number one was requirements for integration. You said no, number one, supply chain. I'm saying number one is actually the design and testing portion. Okay, you know what? When we talk about PLM being an integrated process itself, where the success depends on all the parts, it's true, because we could really argue for any of these being the number one solution here, right? Like the area we need to really dive into.
And supply chain integration is all part of the product lifecycle. So agreed.
All of it. Okay. The entire critical thread. That's
with AI.
Yeah, the way we agree is just by saying that everything matters.
Okay. Yeah, that's great.
No.
Yeah.
I will called a thread.
I will say that executives from both companies have basically come out and said that this is a force multiplier for combat effectiveness, which it sounds like it is.
Mm-hmm.
I guess you guys can agree on this one since it is an article about teamwork, but fine.
Sorry for disappointing the guy whose job is healthy human interactions by being people that can
sometimes conflict is healthy. Okay. Sometimes it's not, but
the funny thing is, our process for talking about these articles is we each come up with what we think is the most important. And we don't really know until we start discussing back and forth whether we agreed or disagreed. So it's not planned to agree or disagree. It just happens based on who's the most right.
We need to work on that.
Yeah.
And with that, thanks everybody for joining us today on another exciting episode of Let's Get Defensive, where we talked about using your elbows to defend against oncoming concrete. That was what we did today, right? Oh no, wrong show again. Okay, on that note, bye everybody.